The GE90 is the world's most powerful commercial jet engine in service. The Boeing 777, the best-selling wide-body aircraft of all time. The combination of the engine and the airframe is nothing short of an engineering marvel. In this comprehensive 777 engine series, we will build up the engine from scratch, and understand how all the components function, as we start and operate it. The engine has two rotor shafts, high-pressure shaft, and the low-pressure shaft. A stator and a rotor, combine to form a single stage. The N2 shaft has 9 such stages of high-pressure compressors, and 2 stages of high-pressure turbine. The N1 shaft has 6 stages of low-pressure turbine, 4 stages of low-pressure compressors, and ahead of them is the massive fan. Before we look at more engine components, let's do the aircraft configuration for engine start. First, the battery switch. Battery provides limited power, good enough to start the APU, a small engine in the empennage of the aircraft. Rotate the APU start switch, hold for a second and release. The APU is online, now we can use the APU generator. Selecting the generator switch establishes full electrical power of the aircraft. During engine start, electrical panels will provide power to the electronic engine control, installed on the engine fan case. APU will also provide the pneumatic power to start the engine. Make sure the bleed switch is in auto position. Next, the fuel panel selections. We only require fuel from the left main tank, so select the 2 left tank pump switches. 2 boost pumps inside the fuel tank. Transfer fuel to the engine spar valve in the wing aft spar section. Aircraft configuration is complete. Let's attempt an engine start. On the engine, the pneumatic pressure reaches the start valve. 777 has an auto start feature. When used, the EEC takes over the entire engine start operation. Now turn the engine start switch to start position. EEC gets the start signal and power to operate. EEC commands the start valve to open, the pneumatic pressure reaches the air starter. The air starter drives the accessories gearbox. Several torque-requiring components are mounted on the gearbox. One of them is the horizontal drive shaft, that connects to the transfer gearbox. The transfer gearbox changes the axis of rotation, and with the help of a radial drive shaft, rotates the N2 shaft. As N2 rises, airflow is established through the core of the engine. Due to the airflow, N1 shaft has positive rotation. Fan rotation in turn leads to bypass airflow through the engine. At 7% N2, a small alternator installed on the gearbox supplies power to the EEC, and the airplane power supply goes into standby mode. Since we are doing an auto start, we can use the fuel control switch, and need not wait for the engine to reach 21% N2, which is the case in manual start. Let's select the fuel control switch to run, and see how the fuel travels within the engine. The fuel control switch opens the spar valve, and the fuel rushes to the main fuel pump. The pump driven by the gearbox increases the fuel pressure, and transfers it to the fuel oil heat exchanger, where fuel picks up heat and cools down the engine oil. From the heat exchanger, fuel travels to the fuel filter. Filter screens the fuel for debris, and transfers it back to the pump. From here, the fuel is sent to the hydro-mechanical unit. The HMU now controls the fuel to the engine for combustion, and any excess fuel is bypassed back to the pump. HMU waits for the EEC command to open the fuel shutoff valve, and EEC waits for N2 to reach 21%. As N2 reaches 21% RPM, EEC sets up the engine for combustion. Out of 2 ignition exciters, EEC commands one to activate, keeping the other as backup. The ignition exciter converts the input power to high voltage pulse and transfers it to the igniter plug. 3 seconds after ignition activation, EEC commands the HMU to open the fuel shutoff valve. Before heading to the combustion chamber, fuel travels through the fuel flow transmitter and back into the HMU. Fuel flow transmitter sends signal to the EEC to determine engine fuel consumption, which is crucial for engine performance monitoring. Fuel is now sent for combustion through 2 manifolds, to which are connected 30 fuel nozzles. Each fuel nozzle has 2 sprayer tips, and each tip goes into the swirler slots in the combustion chamber. The swirlers diffuse the core airflow, slowing them down, ensuring proper fuel-air mixture, and buying enough time for efficient combustion. Combustion gas forces directly affect the turbines. Since they are mounted on the same shaft, increase in high-pressure turbine rotation drives the high-pressure compressor at a faster rate. Likewise, increase in low-pressure turbine rotation drives the low-pressure compressor and the fan. As a result, the rate of airflow through the engine increases, leading to steady increase in thrust. Temperatures inside the combustion chamber is adequate for sustained combustion, therefore at 56% N2, the EEC deactivates the ignition system. At about 64% N2, the EEC commands the start valve to close, and the pneumatic pressure to the starter is cut out, disengaging the air starter from the gearbox rotation. As the engine reaches and stabilizes at the idle power, EEC sends a signal to the airplane systems that the engine start procedure is now complete. This allows the airplane systems to de-energize the start switch latching solenoid so that it could return to normal position, ready for next start attempt when required. Join us in the next part of the 777 engine series as we continue to put the engine through its paces. Thanks for watching.